Okay, guys, welcome back once again to the meeting. Oh, sorry. I'm going to use the camera on the Teams, and I'm going to use it here on the Zoom. Anyway, it doesn't matter. At the end, we're going to have the recording. Or hopefully, we're not going to have a problem with the Teams once again, as we did last time. Definitely, what I'm going to use, because it's much easier for me to download and upload, is going to be the recording from Teams, if it's going to work probably as we used to have every time. Okay, the best thing is I'm going to share my screen, and we're going to start our session. Oh, probably muted somewhere. Yep. Sorry, I'm going to start recording on Teams. I'm going to share my screen on both Teams and the Canvas. Unfortunately, we don't have too many people today. I don't know why, but anyway, I hope that you can see my screen now. Is it working properly? Both? Yep. So people on Zoom can see my screen. Can the people on Teams see my screen as well? People on Teams, can you see my screen? Great. Okay. So today, after we learn all the important terms that we need to use for the writing of the G-code, today we are going to start writing G-code. You can see actually this diagram in front of you. What I'm going to start with is going to be mainly the profile cutting, because this will be the best exercise. Oh, I don't know why I got continuously muted on Teams. Yep, we're going to learn how to use that on the G-code on writing down the, doing the profile cutting, because profile cutting usually is going to be much easier than the face milling or the, yeah, well, maybe we're going to call it the face milling, which is going to do the profiling at the top of the surface of the part we would like to start with. Now, take a look to the part, try to analyze it, and try to indicate first the datum point. I would like you, after we are going to show you this form first, write down something similar to that shape. That's what we call the hand sketch. And the hand sketch is going to be a very important step towards finding the points. I'm going to move my cutting tool around. So go back to the shape once again, prepare your paper and pen, pencil, whatever the thing is, and try to sketch the same diagram on your paper, and then we're going to start with work. Okay, I'll give you something about 5 minutes. Shouldn't be that complicated. What we can see in this diagram that we have straight lines. We have inside circle arc, outside arcs, and we have the full half circle, straight lines, small arcs here, but we don't have any incline shape, because the incline shape have a special trick. I'm going to show it to you during the session. First, we're going to learn how to write the code for this one. Later, I'm going to share with you tutorial for a software you can download as a demo version. It can work for 1 month. You can use it to apply the code we're going to write down at the moment. For me, I'm going to find the points. And then you are going to write down the code by yourself. Then you can share it with colleagues you have here and well, check if they accept what your code is. And well, something like the peer evaluation of the code. Okay, so whoever finished the sketch, just raise your hand. I will give you till 6:06 for the time. Now it's 6:01. Yeah, okay, now Vincent finished with the sketch. Good. Okay, now you got all the dimensions, got the shape as it is. The people, Vincent and Ashton, I don't know who did finish that on the Zoom, try to sketch an offset for that shape. What I mean with the offset is, for example, I will get this line. That's what I did on the Excel, but of course you can do it much easier on the paper. For this line, again, to make an offset line. Like this one, it's parallel to it and offset by the distance of, let's say, 5 millimeters. Why 5 millimeters? I will tell you soon. Okay, so I will make this line again to extend it further. I can do the same thing for the upper one. Copy, paste. And it's going to be parallel now to this one. The one at the top. I'll make it a long one all the way down because we're going to use it later for the other one. And I'll extend this one as well to here. Okay, now I will do the same thing for this line down the lower level. Okay, I'll try to change the color to maybe black so you can distinguish the color. Okay, I will change the color of that to red. I know you may don't like the red, but it's going to be more clear than the one we have. Okay, now what I'm doing with the parallel lines, which are offset by the 5 millimeters, is I try to figure out what will be the path, cutting path. Okay, so I finished with the lines. I still have one line, some lines here, so again to do it again. Okay, so we do have these lines inside. Okay, doesn't matter what the length is. Yeah, again, to leave it long. Okay, and paste, we still have another few lines, and then we start with the arcs. Once again, I usually do that by hand, but I just want to explain to you with more clear view that what will be shape of the line we're going to have here. Copy, paste. Okay, now you can see that while I'm sketching these lines, they are going to intersect. And these intersections are going to be the points I'm going to move my cutting tool center between it. Okay, so that's why we're doing that. That's why I had the red lines, because you can see this 1 point, second, third, fourth, fifth, sixth. Again, to have another 2 here, another 2 here, and another 2 here. So let's start doing that. I'm going to get this one, paste it. Okay, and 5 millimeters. I'm going to change the properties. Oops. The style, nope. So no. I'm choosing the wrong thing. Why does it say? Okay, so we're talking about form and the shape. The line, again, to change it to red. Again, to reduce the point. And again, to make it dashed. anyway, something. Okay, now from here, I'm going to make this straight lines because it won't work like that. So this should go down to here. Yep. And okay, that's also by 5 millimeters. And I'm going to do the same thing on the other side. So I think it's much better to copy that and put it here. I know that's just fancy things I'm doing. It shouldn't be a part of your course, but the main concept is that I'm just trying to, just try to show you how we can make the offset lines. Okay, now obviously you can see that the arc we had here is larger than the actual one. And this will be the trick we're going to learn by doing the outside arc and the inside arc and what will be the difference between them. Okay. Okay, and I think we've done. Now we're going to do the same thing for this circle. I'm going to copy this one and change its properties. Okay, and once again, just take a look. If I'm going to make the inside circle, I need to make it smaller, larger. If I'm going to make the inside one, I need to do it smaller. Okay, so we are getting there. Change the properties. And once again, it's going to be red. And to be small. Okay, and it's going to be dashed. Okay, now what we have left is I need to make straight lines coming up from here. And then I'm ready to locate the points. No, I need 2 of them anyway. So that's 1. And that's the last one. Okay, now let's count the points and let's try to, no, I still have 2 here. So copy, paste. Okay. And paste. This one is going to be horizontal. And done. Okay, now let's count the points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Any questions so far? Is it clear at this stage? All good? We found the points and we can find the coordination of these points. Now, the most important thing is we need to identify where my datum point is because we are going to use the absolute coordinations. For the absolute coordination, all the points are going to be referenced to the point 0, 0, 0, X, Y, and Z. Technically, we're looking now at the top of the work part. Now let's consider that my phone is the work part. I'm looking at the top surface. Looking at the top surface, this will be the x-axis. The lower level, the horizontal one, is the x-axis. This will be the y-axis. Upward is the positive. And the depth from this surface below, this will be the z-axis. Okay? Above that is positive z-axis. Below that is going to be negative z-axis. I'm not going to work in detail with the z now. I'm only going to use it for a while, but it's going to be there. So I'm going to insert a point to identify the datum point. I'm going to use the datum point to be this red dot. Okay, now this red point is the 0, 0, 0 point. Now we said that the distance we choose here is going to be 5 millimeter. You will ask me why I choose 5 millimeters. Can you see these arcs? This arc has a radius of 5 millimeter. That means I don't have to make the code to be written as a G02 or G03 at that point, because the radius of the cutting tool will make the cut as the cutting tool is going to pass here. So this will be the cutting tool. When it's going to come to here, it's going to generate that arc. That's a very important thing you need to remember. In the milling operation, it's impossible to make an inner corner to have 90 degrees. It's impossible. Why? Why it's impossible to make internal corner to have 90 degree sharp? Exactly, because the cutting tool is rounded. So definitely location is going to be rounded. Now, can we actually later make the corner to be acute? The answer is yes, but we're not going to use the milling operation. Later, we can do something like the approaching operation, when the cutting tool will just keep going forward and backward and remove the rounded edge and make it, instead of the fillet, to be a straight one with acute angle, 90 degree angle. Okay, so this is something we don't want to worry about at the moment. We're going to focus on how we are going to move my cutting tool between the points and finish the work. So this is my cutting tool. I consider this cutting tool is going to have the radius of 5 millimeters or the diameter of 10 millimeters, which is very popular cutting tool. It's either going to be made of the high-speed steel, very common cutting tool, but the problem with it is that it cannot work at the high speed, and thus going to take longer time of machining, but it's quite cheap. Okay, and the other way is use the carbide insert. With the carbide insert, I can get the cutting tool of the use of carbide insert and have 10 millimeter diameters. Smaller, usually is going to be tend to be high-speed steel. Okay, now this is my cutting tool is going to move to this position first. Now, take a look. Well, actually, it seems to be that I'm missing something. If this one is going to be 5 millimeter, this line needs to come a little bit to here. Okay, and let's check on the other side. Now the other side is perfect. Okay, so find the location of that point. You can see that this is the 0 point. This will be positive x in this direction. This will be positive y in that direction. And this will make this direction is going to be negative x, and this direction is a negative y. If the distance here is 5 millimeter in the y, and this distance is 5 millimeter to the x, type what will be the location of that point here. Go ahead, be brave. Type what will be the coordination here. Exactly. So we are going to have the point number 1 is minus 5x, minus 5y. I'm not going to worry about the Z now. I'm going to talk about the Z later. Or I can tell you that the depth of the thickness of the work file is going to be something about, let's say it's going to be 5 millimeters. Okay, so the point here is going to be -5, -5, and -5. Now, I'm going to move the cutting tool into, I will move it to the clockwise direction. I'll do the cut in the clockwise direction. Okay, so now let's indicate what will be the location of the cutting tool here. I need to take this one a little bit higher, just to make it more realistic and what is it right now. Okay, now what will be location of the center at that point? I think I'm going to change this one to the no. Okay, now what will be location of the center of the cutting tool here? -5 and 70. Yeah, because 65 plus 5, this will make it 70. That's good. Now we got the other point. Please write down that on your papers. Write down that on your papers. Johnson, do you have any question, or you raised your hand because you finished the sketch earlier? Aye. Okay. So we got the other point. Now, don't mention what the point is, just write it down on your paper. The third point. I'm sorry, this should be the third point. This is the third point. We have 1, 2, and 3, 0, and 70. Fourth point. Okay, you just remember that the radius here is 50 millimeters. So to here, the x is 15. To here, the x is 15 minus 5. Now we go up. This will be my fifth point. Find location of this one while I'm fixing that. Okay. Now, this will be the next point. I think it needs to be pushed a little bit to here. So again, to fix that. Okay, so this will be my next point. I'm going to stop here. And then we're going to go down here. Okay. And cut in circle shape over into, yeah. So this will be my other point. I will come back to you later. So I'm going to show you how to get the points. This will be my next point. If I'm going too fast, just tell me so I can slow down. Just remember that we're referencing all these points to that point. So for example, this one is going to be equal to, so we're going, well, for the height definitely is going to be equal to 65 plus 15 15, this will make it 80, and this will be 85. So the y is going to be 85. For the x is going to be 15 plus 45, that's 60, plus 5, okay, that's 65. Now, I want to know what the diameter of this first cycle. So if the radius here is 20, this is 5, so this will be 15. So this point is 30 millimeter further. So we have 30 plus 5, that's 35, plus 45, this is 80, plus 15, this will be 95. So the x here is 95, and the y is 85. Okay, so you got that point. We're traveling to here and stop. Now, for that point, we were here as 85. We put another 5. This will make it 90. 90 plus 35. This will make it 125. The y is still the same. Now we're going all the way from here down to here. Now both the x and the y has changed, because we went down for the y by the value of 25 plus 5. This will make it 30. So we have 85 minus 30. 85 minus 30. This will make it 55 here. And obviously you can see that it's 55 for the y. Now for the x. For the x, we have 60 plus 40, that's 100, plus 60, this is 160, plus 5, this is 165. So 165 for the x and 55 for the y at this position. Now the y went to minus 5, while the x remained as 165 for this point. Maybe it's not too realistic. Anyway, yep, for that point, we have 60 plus 40, that's 100, minus 5, that's 95. So the point here is 95 for the x and minus 5 for the y. The x's remain the same, 95. But for the y, we got 40 minus 5, so 35 for the y here. And new position, now we got 60 plus 5, that's 65 for the x. The y remained 35. We got 65 for the x and minus 5 for the y. And we go back to the minus 5, minus 5. All good? Take your time, write the code, and write the points, and we will go for the codes. Just remember that if I get to cut an arc from inside, my radius that my G02 or G03 is going to follow is going to be the radius of the actual arc minus the radius of the cutting tool. So in this case here, this spread radius, arc radius is going to be the 15 minus the radius of the cutting tool, which is 5. So the red is 10 millimeter radius. Now, the radius here was 20. The radius of the red one is going to be 15, because 20 minus 5. On contrast, if we are going to go for the outside arc, the radius of the red arc is going to be the original radius, which is 25, plus 5 millimeter, which is going to be 30 in that case. This will help me a lot when I'm going to write down the code for the turning, cutting the arc. Okay, so So far, I think it's clear. And now, let's try to analyze the thing on a paper. You can take a snapshot of that. Or maybe I can take a snapshot. It's going to be quite complicated for me because I'm running two softwares, Excel, and I need to, two screens. So when I get to take a snapshot, I need to cut it and then share it with you. Anyway, we can do that. Anyway, let's give it a try. Different screen. Yep. So, well, I don't think it's worked. I don't know why. Let's try. Did it work? There's one of the things I don't know why I have it. When I got the Chrome working, I cannot take a snapshot. Yep. Okay, you can take the snapshot. Meanwhile, again, to move to the camera and try to analyze the shape, because this is the first code you will learn. Later, again, to send you an email, or again to post that on the Teams and also on the people who are using the Zoom, again to send on the LinkedIn. A part that you will practice or write down your own code. It shouldn't be that harder than this one. Okay. So now, once again, what we've done was I sketched the parallel line. This will be the first thing you are going to do whenever you're going to write down a G code by hand. Okay, we always going to offset that. Just remember, the process again to work on it is going to be the profile cutting for the finishing, because if I'm going to do the starting from the beginning, the rough cutting, I'm going to take further steps. So I'm going to explain that here briefly, but once again, you can practice on that on the major, something like the major assignment is going to be given to you on Monday. Okay, so I got the points here. Okay, and I'm going to consider myself as the machine, and I will try to move between the points as driving. So these are the points. I'm going to go from this point is going to be the point number 1. Point number 2. This will be point number 3. Point number 4. 5. 6. 7. 8. 9. 10. 11. 12. 13, 14, 15, 16, and 17. Because I'm going to go back to here once again. So we have 17 points, and we already got the coordination. Well, it's good to practice, actually, if you're going to write down here the point number 1, and you write down what will be the X, the Y, and the Z. So the X is going to be -5, -5, and we said that the depth is going to be 5, so this will be -5 for the Z. And then we are going to write down the same thing for the point number 2, up down to point number 17. Easy. Now let's analyze the movement. I will come from any place in this space with my cutting tool, and I try to put it in this position. So the center is going to be here. So for example, I'm coming from here, traveling all the way to here. So my first line is going to be N10. and I'll write down in the N10 G90. I need to define that I'm using the absolute coordinates. So I'll write down here G90, and I can write down after that immediately that I'm using the G21. Okay, that's mean I'm using the millimeters. And go to the line number 2, line 20. We said that if I get to 1020, then that's mean I can insert here 9 extra lines. If I have a mistake, I can delete this one and put another one down there. So, and this one again to write down M03. By the way, we can put the program number. We can put 4 number at the beginning to mention that this program number. M03, I start the spindle on. So it's going to start to rotate on the counter in the clockwise direction. So I need to define what will be the spindle speed. So I will say that the spindle speed is going to be, let's say 1,000 revolution per minute. So I forgot something, and I'm going to fix this problem. Here, I can put the N11, and I will say M06, which is stop the spindle for changing the tool. And I will put the tool number 1. The tool number 1 is the tool I'm going to identify in the program, and on the machine, that the tool number 1 is going to be the position number 1 in the third machine. When I said third machine, I think that I explained that to you later, but I'm going to show you a video now. Third machine is something like we have a disk, and this disk have multiple positions for the tools. So we can put minimum 4 tools on any turning machine, and we can take it up to 16 in some of the advanced machine. So I'll say that the position number 1 is going to carry the cutting tool with the diameter of 10 millimeters. So tool number 1 has been identified here, is the 10 millimeter diameter cutting tool. I don't have to mention that here, but just for example, if I'm going to send this code to a friend, I can write down here something like what we do in the programming, in the G coding. So if I'm going to put that, that means it's not going to read after this point. I will say that the tool number 1 is 10 millimeter diameter. Okay, so the people will understand that tool number 1 means 10 millimeter diameter cutting tool. So I start here the spindle, and the RPM is 1000. I will move the cutting tool from anywhere in this space to the position number 1. So the N30 is going to be G00 to the X is equal to -5. It's good practice to put 0.00. Because now this program is, we just got the full number, but maybe we're going to have, especially in the inclined services, we're going to have fractions. So the Y is going to be -500, and the Z is going to be equal to 10 millimeters. So I'm going to take my cutting tool above this position, moving up the level by 10 millimeter height. We can actually put something here saying that the feed rate is going to be 250, and the machine will understand this is 250 millimeter per minute. Line number 3 is we are going to go down to the level of -5. So this is G01. The X and the Y not changing, so don't need to write it down once again. Just write down that the Z is equal to -5 millimeters. I can keep the same feed rate. Just go down at the velocity of 250 millimeter per minute. Now, my cutting tool is in position. And to explain that much further, so we said that my phone is the part And from the side, that's what will happen. My cutting tool is facing, going inside by 5 millimeter depth. So the side of the cutting tool is what cut the side of the wet part, where it's going to move around and do the profile cutting. Is that clear for you guys? I'm going to show you that. Well, actually, the example we're going to have on Monday is going to be more complicated, and we'll show you a lot. But that's the side of the cut of the work part. It's cross section. My cutting tool now is standing here. The center is here. This center is away by 5 millimeter, and this is 5 millimeter depth as well. So the Z is -5. Okay, now, if I would like to move from here to here, the movement is a straight line. It's a straight line in G01. So please write down the line number 50. Line 50. G01, you don't have to repeat it because already we are written. And write down the code, just change the X is going to be the same, the Y is going to be different. We said that the height is actually from here to here is 65 plus 5, this will make it 70. So the Z is going to be the same. So you're only going to write down that the N50, G01 is the same, X the same, the Y is going to be 70. I may change the feed rate to be 200. Z is going to be the same. That's usually something I do. I always keep the space, but actually you don't have to keep a space. I keep space to make the Y below the Y, the F below the F, the Z below the Z. But actually the machine not going to read it like that. Just write it down close to each other. Now, to point number 3 is G01. What will be changing is going to be the X. So the N60 is going to be the X is equal to 0, 0, but everything else is the same. Now we start the new trick I need to teach you. We're going from here to here, from here to here. This is counterclockwise direction. And in counterclockwise direction, we're using which term, which code? Clockwise G02, counterclockwise G03. So my next line is going to have G03 at the beginning, and then I need to identify the location of the next position, which is the point number 4, and also the radius that the cutting tool would like to have. We can do that either by using the I and the J, or we can do it by writing the R directly. I will do it both here. And then I will ask you to spend the rest of the time writing down the code till the end. N70. Okay, so we're going to write down G03. And now I need to identify the location of the point number 4. The point number 4, the height will be, difference is going to be actually 65 plus 15, and this will make it 80 for the Y. But for the X is going to be equal to 15 minus 5, this will make it 10. So the X is equal to 10, and the Y is equal to 80. And the radius for this small arc is going to be equal to, we said, take a look to the shape. We said, if this one is 15, this one is offset by 5, so it's going to be smaller by 5. So the R of the red arc is 10 millimeters only. So the R is 10 millimeters. Or I can write down as the I at the J, and I only need to define what will be the location of the center. So the center definitely is going to be here. Okay, this will be the center. So the center in the I is going to be equal to 0. And for the J is going to be 80. So the machine will understand that I'm moving from the point number 3 to the point number 4. And because we have the G03, that's means we need to calculate the radius, and the radius will be calculated to be 10, exactly the same. One of the practice we have to do when we cut the arc is we're going slower. Otherwise, the edge will be cut as cutted, so it's going to have a bad finishing. So we always going slower when we make a curve. So I can write down the F here to be, for example, 120 only. Okay, now I would like you to finish the code. Go from 4 to 5, straight line. 5 to 6, straight line. 6 to 7, straight line. 7 to 8 is going to be a curve, and this will be counterclockwise again. So G03. 8 to 9, straight movement. 9 to 10, straight. 10 to 11 is going to be an arc. And this will be on the clockwise direction. And 11 to 12, straight. 12 to 13, straight. 13 to 14, straight. 14 to 15, 15 to 16, 16 to 17 are all straight. Okay, so finish the code for me. Okay, I'm not going to check it for you now, but you will check it yourself. How? Again, to once again share the tutorial with you, you need to download the Cnc Simulator Pro. Following the steps I'm going to send you for the in the tutorial. It's 25-minute tutorial, step by step. If you follow this step-by-step tutorial, you can put your code in, and then you will be able to simulate the work and got the shape cutted. Just remember that what we are going to have for the part is the dimensions are actually for the X and the Y are here are clear, but the thickness is going to be 5 millimeters. That's what I would like you to do later in your checking. Okay, so I'll be here sitting, waiting for you to finishing the code. I got the first 7 lines. Actually, it's not 7, it's 8 lines because we have an 11. And if you have any questions, just go ahead and ask. I would like you to consider yourself as the machine. So when you write down the code, you can simply check it by moving your pen on the paper. Read the code and move the pen on the paper. And this will help you a lot on doing the work. Just remember that next session is going to be for 3 dimensions. The session after is going to be for the turning operation. And the other 2 sessions is going to be for the CAD CAM. Okay, so go ahead. You think you can do it, right? You're positive you can do it. But it's not that hard, actually. It's interesting. And once again, you'll say, okay, now why we have to learn that? Because sometimes you have a desktop CNC machine, and you will see that it's much wiser to spend the time on writing down the code rather than sketching the CAD model and generating G code, especially if it's going to be a simple part. Or a part is going to be too complicated to be sketched, but easy to be analyzed. Whoever finished first, just tell me. Okay, so now we will continue with the rest of the code. I will write it down here. Unfortunately, and again, to be able to see the sketch, I have a question. How do you know what the number to use for the block number and why you did choose N10 to start with it? Okay, now, um, actually, I did that on purpose. And if you can see here, I put N10, then N11, and then N20 because I wrote down the N10 first. Then I wrote the N20. Then I said, wait. I forgot to change the tool. I forgot to set up the tool. And this is a very important point. So I went back and put a line in between the 10 and 20. I called the N11. Okay, so this will allow me, I choose 10 by 10. This will allow me to insert a line in between just in case I forgot to put a block that's going to make a certain movement. Does that answer your question, Arma? I'm sorry, I need to show the question to the people on Zoom. Um, so this was the question. He said, I have a question. How do you know what the number uh, for the block number? Okay, and what you do, they choose the N10 at the start. And the answer is shown here. Okay, I use the N10 and 20. Then I said, wait, I need to put an extra line. So I just add the N11 in between them. If I didn't do that, if I wrote down N1, N2, N3, and I had this mistake, I need to change the number of all the lines. So why do that? Just simply make them by 10. So you're going to have something like 9 slots are available as an extra slot, so I can use them. I hope this will answer your question. Okay, now we go with the rest of the code. Just remember that standing here at the moment, and I'm going to continue 5 to 6 to 7 to 8 to 9, 10, 11, 12, up to back to 17. So the code is going to be as following. The N80, I need to change back to the G1. So G1. And I will choose that the X is actually remain the same. The Y is going to be changed by 5. So the Y is going to be 8500. And I will change the F to be 200 again because I don't need to be slow in the straight cutting. And 90, no G01 needed. I'm going to move from 5 to 6. And the 5 to 6, the X will be changed, but the X not going to be changed. Now, how much do I have here? I have, I need to see the Excel sheet. Okay, so I'm going to 60 plus 5, that's 65. So the X is 6500. Anything else? No. And 100. The X remain the same, the Y will be changed. We are going to go down by 5, so the Y is going to be equal to 80 millimeters. Now, I need to go from the point number 7 to the point number 8 by circular interpolations. So that's what we're going to have. Now I'm here. Okay, and I need to take it to here. So the X and the Y of that point is going to be required. Okay, X and Y of that point is going to be required. The Y is going to be, it's telling me that the time is about to over, doesn't matter. We're going to almost finish on time. Okay, so you can see that the Y is going to be 80, but the X is going to be changed, which is going to be equal to 60 plus 40. This will make it as 100 minus 5. This will make it 95. So the X is going to be equal to 95 and the Y is going to be equal to 80. And the radius of this line is going to be 15. Now, I need to write down, this is G03, because this is counterclockwise. The X is 95 degree, the Y is 80, sorry, the millimeters, 80 millimeters. The R is 15. The feed rate is 100. Again, to go too slow. Now here again to leave the I and the J for you. Now I will go straight upward. So the N120 is G01. The X remain the same. The Y is going to be 85. The feed rate is, I will leave it, well, I like 200. I don't want to be lazy. And 130, I would like to go down to the point number 10. In the point number 10, the Y is the same, but the X is going to be changed. And this X is going to be equal to, I think it's 135. 135. Now, how did I calculate that again? 15 plus 45, that's 60, plus 40, this will make it 100, plus 35 to here. Okay, this will make it 135. 135. Now, and 140. Actually, this is a good thing to see the whole code. Now we're going in an arc. We're going to make the circular interpolation from here to here. So once again, what was the radius of the red arc here? What is the radius of this red arc? .30. And what is the coordination of that point? (165) for the X and 55 for the Y. Okay, so the direction of the movement is clockwise direction. So I'm going to use the G02. So G02, we're going to the X is equal to 165, 0, and the Y is equal to 55, 0. The R is equal to 30, 0, and the feed rate is 100 milliliter per minute. Now, the rest is going to be straightforward. Well, again, to move in G01 all the way back to point number 17. So the N150 is G01. The X remains the same. The Y is equal to -5. Okay. The feed rate is going to be 200 because it's going to be wiser to move faster, finishing the cut in shorter time. Now, I may mention that earlier. Now, for the how fast you go for the RPM or how fast you go for the feed rate is a very tricky thing. It's actually a study done by Taylor, which is a person who made a Taylor formula for the tool life. He said, you can cut faster, shortening the time of the machining, but you will sacrifice your tool. Well, I just give you the brief of his theory. So he said that the velocity multiplied by the time of the machining up to power n is equal to a constant. That means higher velocity or high cutting speed will reduce the time, okay, and vice versa. Slower, you're going to increase the time. So if you're going to multiply both, where the t is going to be taken to the power of the n, which is the slope of the multiple speeds. Well, that's mean if I'm going to have a curve between the speed of the cutting and the tool life, is going to be a straight line going upward, downward. So lower speed, longer life, and so on. But the time of the machining is going to be increasing. So we need to make a multiple calculation until we're going to have optimum time with the optimum speed of the cutting. That's why I just keep changing that. I would like to have good quality, but I would like to shorten the time of the machining. Usually the average time will depend on the cutting tool type and the material we are cutting. Okay, G01, we go to this point, and then we are going to go to the, now we are here. And we would like to go to that point first, which is going to be 95 for the X. And the Y is remain the same, -5. And then we're going to go to here where the Y is going to be equal to 35. So I'll write down these two steps. And 160, I don't write down G01 again. The Y is remain the same. The X is equal to 95, 0. And the N170, we're going to the Y is equal to 35. The X has remained the same. The step after, 180, we're going to the X equal to 45. 65. The Y remains the same. The N190, we're going to the Y is equal to -5. And finally, we go to the N200, where I'll write them both. The X is equal to -5. The Y is equal to -5. Okay, and finally, we are going to go up the word part. And 210, the Z equal to 10. And finally, we need to turn off the machine because it's very important. And 0, 0. I will go upward a little bit So the whole code now is in the front of you. Okay, and we're done. Now, if I would like to check the other way around, I mean, I will read the code and sketch. So I can read the code and sketch the points. And this will tell me what will be the shape again to have for the toolpath. Undersize it, this will give me the shape of the part I will cut. So it's going to be the reverse way of reading the code. So usually back in the old days when I used to have the exams for the advanced manufacturing, I either give them the code and they need to sketch the part, or I give them the part and they need to write down the code. Depend, I was playing with that. And the assignments, again, to show you an example of the assignment we had in the advanced manufacturing. I think the student in the advanced manufacturing remember that. But actually, the things getting more advanced in the past 2 semesters because of the COVID lockdown, and we need to have more variation for the shape. And the example I'm going to give you on Monday is going to be quite complicated, but it's going to be a big enjoyment, actually. It's going to be a good challenge. And also you can put it on the simulator. Now we're going to the simulator part. For the simulator part, where's my, yep. Okay, so that's a simulator called Cnc Simulator Pro Trial version. This can be last for 1 month, and you can download on your computer for free. It's going to give you a 3-dimensional simulation of your part. Very easy. You only need to put your code here on that side and run it. But there's a certain setups going to be required. The first thing we are going to do with this simulator is writing down the same code we worked on at the moment. So I'm going to share the code here. And I'm going to share for the Zoom people, and also again to put it down on LinkedIn, so the other people who listen to things can watch it and try to apply the same code we wrote down on this paper. Okay, now a new session, new knowledge. Be honest, did you like this session? It was misleading. Good. I started to have some people who liked it, which is good. The chat for the Zoom. Good. Now, well, you're gaining new things, new ideas. It's not that hard, and it's going to be very useful. Now, actually, when you're going to check the simulator tutorial, and you will find that the things actually start to move in the front of you. You will like it even more. That was good. We didn't finish yet, Johnson, so we still have too much to go through. Okay, we just understand the basics on how to write down a new code. And I can guarantee that at the end of this course, you will be something like a semi-professional. When I say semi-professional, that's mean you'll be able to read the code, understand it, and make it your own. You can take any part, analyze it, and you can write down the code for it. And just keep practicing. Boom. You can add this as a skill in your resume. That will help you out, actually, as I mentioned there, to find internship, find jobs, and make sure. Okay, I usually all my students who I taught earlier made a show off with this G coding. So I hope they're all going to have the same thing. Okay, so I don't want to take on your time. We passed 8 extra minutes, and I don't want you to feel bored of this session. We're going to stop recording at this stage. Once again, the recording is going to be available on Teams and on LinkedIn. And I will find a way on how to share it with the others that don't have the access to YouTube, for example. Because, well, for Teams people is going to be available as we stop the recording. And for the LinkedIn people, it's going to be on YouTube. If anyone have a problem with accessing this tutorial for the simulator, just tell me and I'll try to put it on a website that can be opened, for example, in China without any problems. Okay, so we stop the recording here. And again, to stop the recording on Canva, on what is that? How to stop the recording here. That problem, I'm not that good with the Zoom. Sorry for that, Zoom people. Okay. Where is it? Ah, yeah. Stop recording is here. Are you ready?